My name is Zev Dresden, and this is my Planet Venus presentation for astronomy. Today I will be talking about the Soviets' Venera missions. A little bit about Venus. Venus, Earth's nearest planetary neighbor, presents a captivating study in comparative planetology despite its apparent similarity to our own world. Venus exhibits starkly contrasting conditions. Venus rotates clockwise on its axis, which is very much opposite from most of the planets in our solar system. It takes Venus 243 days to rotate once. The surface temperature of Venus is 900 degrees Fahrenheit. It is very much hotter than Mercury, even though it is further away from the Sun. Venus's atmosphere is 96% carbon dioxide as well as 3% nitrogen. This planet's atmospheric pressure is 90 times than Earth's. Venus has many large volcanoes across the planet. Venus has no moons like Mercury due to proximity to the Sun. Venus is named after the Roman goddess of love and beauty. Why pursue Venus? The Soviet Union's Venera program was a series of space missions aimed at exploring the planet Venus. These missions, which took place between 1961 and 1984, marked the first significant efforts to study Venus and achieve several historic milestones in planetary exploration. The Venera program provided crucial data about Venus's atmosphere, surface conditions, and other characteristics, advancing our understanding of the planet. Now I will be talking about the different successful Venera space missions that made an impact in the world of astronomy. The early space probes were used to be indestructible to get through Venus's harsh atmosphere. Venera 4. Venera 4, the first space probe successfully launched to Venus in 1967, had a relatively simple design. The lander was a 1-meter wide titanium sphere. Inside the probe was pressurized inside to approximately 25 atmospheres. The reason why they used 25 atmospheres, so it was pressurized to 25 atmospheres so it can withstand the harsh pressures of Venus. The probe had no thrusters but a large number of parachutes to create drag to softly land on the ground of Venus. The parachutes created a problem when Venera 4 had the expectation to fall through the atmosphere very quickly. Unfortunately, Venera 4 rammed into the atmosphere like a brick wall. The spacecraft slowed down to 17 kilometers an hour, which was way slower than expected. Venera 4 successfully collected data for 90 minutes in Venus's atmosphere until ultimately being crushed by the high pressures of the planet. This mission is how the Soviets also figured out that Venus's atmosphere was mainly composed of carbon dioxide. Venera 7. Launched in 1970, the approach for Venera 7, Soviet scientists needed to figure out a way that the spacecraft could pass through the atmosphere before it had time to crush or melt the probe, due to the hot temperatures of the atmosphere and pressure. The Soviets took an approach to redesigning the probe, making it a lot more aerodynamic to make it fall through the atmosphere more quickly. They added a cord to the parachute to make sure it does not open right away, creating a much quicker fall until the parachute got way too hot at 200 degrees Fahrenheit, where it would open up and start to melt. Venera's engineers also added walls 2 times thicker for protection and more protection so the probe could now withstand a pressure of 180 atmospheres. When Venera 7 launched, everything went according to plan until the parachute broke off during the descent through the atmosphere. This happened only 3 kilometers away from ground. The spacecraft went plummeting into the ground. The Soviets thought this mission was a failure until they took a look at the data 3 months after and found the lander survived the crash and gathered as much data as possible with the very weak signal it had to work with. They found some mind-blowing data stating that the temperature of the surface of Venus was 500 degrees Celsius. Due to this picture right here, that kind of shows how the 500 degrees Celsius and how hot certain areas of Venus is. Venera 9. Launched in 1975, transmitted the first black and white images of Venus's surface. These pictures revealed a rocky landscape with scattered flat stones resembling Earth's volcanic regions. This shows a similarity that Venus has to our planet Earth. Venera 9 used a large air brake to slow down the spacecraft from crashing instead of using parachutes, as well as a set of landing legs to absorb the impact. Venera 9 had a big camera system to capture more area space. As you can see on the picture to the left, that is the camera system. Those two like silver kind of bullety metal things, those are the cameras for the 360 view of the rocky landscape. And to my right, or to like the right of the picture, that this air brake right up here is what they used instead of a parachute to create a little bit more drag and safely land in a more efficient way. The camera system on Venera 9 is a very important factor. It had two movable cameras on both sides and captured a 360 panorama of the surrounding landscape. As you can see, these 360 panorama photos of the landscape of Venus. Venera 13 and 14. Several Venera missions carried instruments to analyze Venus's atmosphere and surface material. Venera 13 and 14, launched in 1982, used a drill to collect and analyze soil samples, confirming that the surface consisted mostly of basaltic rock. Venera 14 caught the first in-color images of Venus, as well as got the first recording of a live drilling in Venus's surface. Venera 15 and 16. The Venera 15 and 16 missions, launched in 1983 and 1984, used radar imaging to map large portions of Venus's northern hemisphere. The radar systems allowed scientists to see through the planet's thick cloud cover and provided the first detailed topographical maps of Venus. Thank you guys, and I hope you guys enjoyed the video.